Hello everyone, welcome to this video. In this video, we shall be looking at question 10 from exercise 9.2. So here in this question, they are saying that if the sum of first p terms of an AP that is equal to the sum of first q terms of an AP, then we need to find the first sum of the first p plus q terms. Right, so here it is given that SP is equal to SQ. We need to find what is S of P plus Q. So because it is given that SP is equal to SQ, we can apply the formula here. No information about the first term and no information about the common differences available to us. So that means in order to calculate this S of P plus Q, we are solely dependent upon this relation. So that means we only have to use this relation in order to calculate the value of this SP plus Q, correct? So let's solve and simplify this. SP is equal to SQ. You can write the formula for SP. It would be P by 2 multiplied with 2A plus P minus 1 times of D. And what would be SQ? It would be Q by 2, 2A plus Q minus 1 times of D. So here you see this 2 and this 2 cancels with each other. So we are left with P into 2A and plus P into P minus 1 of D. And on the right hand side, we would have Q into 2A plus Q into Q minus 1 times of D, right? So now we can shift all the terms to the left hand side so that we would have P, we can take from these two terms the value 2A common. So it would be 2A, this P as such, and then when this term is moved to this side, we would have minus Q. So it would be minus Q. Then from this term and from this term, we can take D common, right? So that we would have here P square minus P, right? And here Q square, this is plus Q square. When you shift this term to the left hand side, it would be minus of Q square, and then minus of Q. When you shift this to the left hand side, it would be plus Q, right? So this term here. So from here you can rearrange and solve this one. So this term is as such, no change here. Now here you can write P square minus Q square together, and you can take minus common and write P minus Q, right? There is no issue. Now you can apply the equation, this equality, that A square minus B square is equal to A plus B, A minus B. So using this thing here, we may write P square minus Q square as P minus Q and P plus Q, right? Next, what we can do, we can take P minus Q common from these terms, so that, and in fact we have P minus Q here also, so we may take P minus Q common from all three terms. So P minus Q multiplied by what is left behind, we are left behind with this 2A, right? We are left behind with plus as such, and this P plus Q, and here we are left with minus 1, and the whole of this term is multiplied with D. So whole of this term is multiplied with D is equal to 0. Now you see, either this is 0 or this term is 0. Now this cannot be 0. If that is so, we would have P would be equal to Q, but this is not the case, right? So that means only this term would be equal to 0. So we have this term as equal to 0. So let's mark this as equation 1. So this is one relationship that we obtain by solving our relation. Now here we wanted to calculate the sum of first P plus Q terms. So that means we are required to calculate S of P plus Q. Now when you solve this S of P plus Q, you would have P plus Q divided by 2 multiplied with 2A plus P plus Q minus 1 into D, right? According to the formula, S of N is N by 2, 2A plus N minus 1 times of D. Here in place of N, we are using the term P plus Q, right? Okay, now if you look at the term here closely, 2A plus P plus Q minus 1 times of D, this is exactly the same term as this one, 2A plus P plus Q minus 1 times of D, and here this expression is equal to 0. So that means this expression is also equal to 0 using our equation 1. So we have this thing, P plus Q divided by 2 multiplied with 0, so that our right hand side becomes 0. So that means the sum of first P plus Q terms is nothing but 0. Hence the answer to this question, the sum of first P plus Q terms of the given AP is 0. Well, that is it for this video. Thank you for watching.